Hallo Karl. Moment. So, jetzt müsstest du die unmuten können. Hallo.
Ja, hi.
Super, wunderbar. Das schaut super aus. Scheinbar funktioniert das gut. Können wir ganz kurz einen Technikcheck machen und schauen, ob du deinen Bildschirm teilen kannst?
Ja, das
Ich
wollte ich
werde,
schon machen, aber ich durfte nicht.
ja, du darfst nicht ganz genau. Moment, ich werde den hier sofort stoppen. Aber jetzt müsstest du können. Probier mal bitte.
Ja, Bildschirm freigeben.
Na, das
Ja,
sieht doch
super.
wunderbar aus. Das sieht doch hervorragend aus. Ausgezeichnet. Super. Dann sind wir gut aufgestellt. Ich werde wieder so um 17:30 Uhr eine kurze Einleitung machen
Ja,
und dann im Prinzip an dich übergeben. Dann teilst du deinen Bildschirm und dann machen wir es in bewährter Art und Weise. Ist es wieder gut so, wenn ich während am Ende, wenn du soweit bist, dass ich dir vielleicht die Fragen, kann ich dir mitgeben oder schaust du selbst im Chat und im Discord mit? Wie ist es dir lieber?
ähm, also ich hab mir hier ein bisschen Code vorbereitet. Das heißt, ich sehe Discord nicht.
Okay. Das heißt, wenn irgendwelche
Genau.
Fragen da sind, die ad hoc gerade reinpassen zu dem, was du sagst, darf ich dir
Ja,
das weitergeben?
einfach, genau.
Super.
Ich
Ausgezeichnet,
muss jetzt noch gerade
hervorragend.
den Bild fixen, weil natürlich geht's 5 Minuten davor nicht mehr.
Das heißt, ich muss etwas länger reden, das ist kein Problem, das kann ich normalerweise.
Na, na,
Okay, super.
das macht dir keinen Stress. Das ist kein Problem.
Alles klar, alles klar. Ich sehe auch, dass Klaus schon da ist, unser zweiter Sprecher. Ich vermute, das ist der Klaus, unser zweiter Sprecher. Ich werde mal hier auf Ask to Unmute klicken und schauen, ob Klaus uns schon hört und ob es
Ja,
der Klaus ist, der heute unser zweiter Sprecher ist.
ja, schon.
Super,
Hallo.
ausgezeichnet, wunderbar. Ähm, Klaus, können wir auch kurz einen Technikcheck machen? Vielleicht entweder Video, falls du dein Video teilen willst, beziehungsweise Bildschirm teilen, damit wir sehen, ob das funktioniert.
Ja, Moment. Video müsste eigentlich gehen. Ja, schiebe ich noch irgendwie. Richte ich da noch her? Moment,
Ja,
ein
ja.
Screen Share.
Ja, das sieht super aus. Das sieht super aus. Wunderbar.
Perfekt.
Ausgezeichnet. Ja. By the way, for those of you who just joined, we are just talking here because our both speakers are native German speakers. And of course, we will switch to English as soon as the meetup will start, which will happen momentarily. I think we will wait for another 1 or 2 minutes and then we will start. So bear with me and stay with us. We will start momentarily. Danke, Klaus, danke, Karl. Klaus, ich darf dich in der Zwischenzeit auf Mute stellen und nach dem Vortrag von Karl haben wir Zeit genug, das alles herzurichten und wir freuen uns schon auf eure Vorträge. So. Okay. Stefan, I started the recording just to let you know. I did not forget. So we will have a recording, we will have videos just with like the previous meetups. And then I can share my screen. Nice. Okay, ladies and gentlemen, welcome to our Rust Meetup, 4th edition. It's 5:30 p.m., so I think we can get started. We are looking forward to having two great presentations again today. But before I hand over to the first speaker, I would like to share some community news with you. Stay with me for a few more moments until we will start. But the Rust Meetup is, as always, brought to you by the Coding Club Linz. Coding Club Linz is a community of IT and programming specialists who love to meet and who love to talk about code. And today we would like to say a special thank you to Microsoft. Microsoft sponsored this Rust Meetup. Currently, in the time of virtual meetups, sponsoring is not that necessary, but we really hope that in the next month we will also be able to switch to in-person meetups, and then we will be very, very happy about the money that we got from Microsoft to offer some drinks and to get great speakers in person to Linz. So thank you to our sponsor, Microsoft. Today's speakers, Carl will start with his talk about building a web extension in Rust. And our second speaker is Klaus, who will speak about trusted computing with Rust and Intel SGX. We are really looking forward to both talks. And thank you, Carl, and thank you, Klaus, for joining us for the Rust Linz meetup. If you would like to join the discussion, if you would like to give feedback, if you would like to ask questions, one of the best way to do so is by joining our Discord server. Here is the introduction, here is the invitation URL. Just type in this URL or take a look at rust-linz.at. There you can also find the link. Join us on the Discord server and join the discussions around today's talks and in general topics around Rust. Now, some community news. The first one, our very own Coder Dojo Linz. For those of you who don't know Coder Dojo, it's a programming club for kids between 8 and 17 years. We are doing currently virtual meetups every Friday afternoon. There are a lot of workshops ranging from Scratch to JavaScript to Minecraft, things like that. We invite kids to come and learn about those topics that are interesting for them. The next meeting will be this Friday, November 13th. If you want to know more, here is the link. Just go to our website with your kids maybe and take a look whether there is something that you might be curious about. Our friends at Female Coders, they will do their next study group on the 25th of November. It will be an online study group. If you're interested in that community, that great community from Linz, here are the meetup pages, the meetup page and their homepage. Check them out. They really do great stuff. The .NET Community Austria, that's not a meetup in Linz actually, but it is the next .NET Community Meetup. And I know that some viewers of this Rust Meetup, especially here in Linz, also do a lot of .NET work. Therefore, I added this news item here because the .NET Community Austria will also happen virtually. It will be on the 24th of November, and it will cover a very current topic, namely .NET 5 and C# 9. So if you are not just a Rust enthusiast, but also somebody who is interested in .NET and C#, check out our friends at .NET Community Austria. Next community news item, the third Cloud Native Computing Meetup will happen also on November 24th. And I think they have two very interesting talks. They are Kubernetes related. So if you work in the context of cloud computing and you are interested in those topics, definitely visit the Cloud Computing Meetup in Linz. It's a rather new meetup. They also started just like we also started here in Corona time. And yeah, I think these guys do a really great job. Everybody who is interested in cloud native computing should check them out. Last piece of information, another sponsor news. Microsoft asked us, they are our sponsor, so we very much welcome their news items and are happy to share it with you. They offer so-called cloud transformation workshops. So if you are interested in any topics related to the Microsoft Azure cloud, check that out. It's an aka.microsoft link, discover Austria-Azure. These workshops are mainly, I think, completely completely free. So Microsoft offers these learning paths for free, and yeah, we say thank you for that. And again, thank you for supporting our Rust meetup. And with that, I am through with the community news. And let me stop sharing here and ask Klaus if he is ready to take over. Klaus, please. Oh, sorry, not Klaus. I'm very sorry. Carl, of course. Carl will start. My fault, my bad. Now, Carl, you should be able to unmute yourself.
Yes,
Awesome.
I should. Okay, cool.
You should be able to share your screen as soon as you're ready.
Yes, just a moment, and thank you very
Yeah, no
much for the
problem.
introduction. So, I'm just gonna see my beautiful desktop for a moment.
Oh yes, a really beautiful picture.
So yeah, hi. I'm kind of nervous. I hope that's not too audible. I'm gonna talk about web extensions in Rust today, and the premise is kind of I did it because I can. My experiences today are from trying to port a web extension from JavaScript to Rust, because after I built it, I just realized, hey, we have WebAssembly. What stuff can I do with it? And yeah, so I just sat down and started trying to build this web extension. And yeah, the purpose of this talk is just to give a little insight into the bits and pieces, how to piece it together to get something working. We're gonna build, yeah, not great stuff, but it's in Rust, so it's awesome anyway, right? Now that I told you why we did it, or why we do it, let me tell you how. A bit about web extensions. For those who don't know, those are the add-ons you can install in Chrome and Firefox, in Microsoft Edge, and even in Safari. So it's a common standard. And the extensions are built on web technology. So we write the extensions using JavaScript, HTML, and CSS. That's why they are called web extensions. And today we're going to learn a bit about the basics. That's apart from the Rust part. Then we're going to experiment a lot with it. And at the end, I want to talk about a nice build job so you can build the things you want to do comfortably. At the heart of web extension, there's a manifest JSON. That's basically a bunch of metadata, what resources you want to load, and the rest of the structure of the web extension is really up to you. So that's good because we have a lot of flexibility when we want to automate stuff. And then I'm just going to show you a really simple manifest JSON. That's just telling the browser, hey, I have the extension named Carl's GitHub Enhancer. That's adds vital info to GitHub repos. It has a content script that matches the domain github.com. So we have a permission model, and with the content script matching, you can basically just say, hey, I don't need every domain, I just need this domain. We also have other permission models, which I will come back to later. And yeah, so we have this manifest JSON, we have some files somewhere. How do we distribute it? It's basically just a zip file. When you upload your extension to the Chrome or Firefox web store or extension gallery, you just upload a zip file. Except for Safari, because that needs to be different, you build a whole app out of it. Luckily, there's an easy command to do that, so we don't have to play around with Xcode. Yeah, so that was a short introduction. I'm going to talk about a few details in the coding session. So I'm going to switch to my editor, and that's basically the main part. Didn't prepare many slides. Let's search for Visual Studio. Okay. I have the package folder in my project should be yeah, exactly. That's the manifest JSON we are generating. So as I said, that's just a bunch of metadata, description. We have a content script for Rust Linz AT. That's going to do something. I'm going to show you in a minute. We have some web accessible resources. That's another permission thing. Because we work with Rust, we have to add our WebAssembly files here to load them in. That was one of the hiccups I found. And the yarn log is only there because I was a little too lazy to remove that from the automation. Then we have permissions. We want to access the storage. That's going to be important later. For the first extension, it's not really relevant. Down here, that's just things to make Firefox happy. They need some Gecko ID, so that's there. And yeah, as you can see in the package folder, I have node modules, which is a web extension, which contains a web extension polyfill. That's there because even though it's a standard, all the browsers kind of understand efficient development is best done with this polyfill. So our base of coding is Firefox. And then for Chrome and Microsoft Edge, we use this polyfill to just cut down on development time. We have some stuff that's going to be relevant later. And yeah. So I'm going to show you my Firefox here. And I want to show you what the extension does first, and we jump into the code in a moment. So whenever you visit Rust Linz AT, in the console, it says, "Hello, Linz." That's really one of the first steps I took with my non-Rust extension too, just get some output anywhere to see if it's working. And let's jump into the code. I have a scripts folder here, which contains sub-projects, which contain the extension scripts. And this is really, really simple. When we work with the when we work with the web extensions, we work with WebAssembly. So everything you know from working with WebAssembly in other projects applies here too. And we just import the log1 function from WebSys and put a JS value in there. And that's our console output. But that's not really much, and it's not changing something about the website. So the next thing I did was just search any element I could alter in an easy fashion. And for GitHub, I choose to replace the logo. Let me open my terminal here. And let's change into the scripts folder. So because of the way I set up the project, every script I write is its own contained Rust project. So to create a new script, I just say cargo new GitHub logo replacement. And I'm going to talk about the build process later again, so you can know what's going on. I forgot to say it's a library. With every WebAssembly project, you have to set the library type. So we need our CDI lib. I just needed to look at my example to quickly spy on the spelling. So to get a WebAssembly output, we need to say this is a CDI lib. And for a WebAssembly project, we also need wasm bindgen as a dependency. Okay, so as I said, the thing we want to do here is search for the GitHub logo and replace it with something. Let's just set this up really quick. By the way, my project setup really confuses Visual Studio Code for some reason, so my autocomplete is not always working, which might hinder a bit, but we'll get through it. So if you ever worked with WebAssembly and Rust before, we have some macros to use, and one of those macros is wasm bindgen. And if we use this macro with an extern C, we can import JavaScript functions into our code. So in the other example, I imported the log1 function into my code, so I can log to the console, but there's actually another way. I can just import the log function from JavaScript. The way that's working, I'm defining my function that's named log, and it gets a message, which is a string pointer. Now, the wasm bindgen macro has some settings, basically, that's about namespacing. It even has some sugar about catching errors and async functions, but we don't use that now. We just say this function is in the console namespace. Okay, and then of course we need some entry point to run this code. And you can either export a function to JavaScript and then call it from the JavaScript part, but I just want to write Rust here. Not a single line of JavaScript is in this whole project. So what we do instead, we define a public main function, and we export it with wasm bindgen again, and with a start parameter. So now when we load the WebAssembly, it automatically starts our function. And because we have the log function, we can now just say log test. And I'm gonna make that a reference. And now I need to edit my top cargo toml because I did some stuff here. I'm gonna explain it later. And oops. Basically what I do here is I have an array of content scripts, and I just added my, oh, that's the wrong script. I need the other one down there. And I add my cargo toml here, and it gets built automatically in the background and is inserted into the manifest JSON. So if I type make here, we should get a new manifest JSON in a moment. Of course, it's not working. I just fixed this because before I started the talk, and now we're going to do some live debugging. I just love it. It's wonderful. Let's see, where are we? Can't find library. Oh, yeah, of course. It's a bit be librs and not main rs. Okay, that was an easy fix. Cool. Now come on. Yeah, it's taking some time right now, and we get another error. Cannot find function log. The best examples are those that don't work when you use them, right? Wait, cannot find log. Am I blind? Okay, I don't think this needs to be a reference, but I don't think that will fix the problem.
Carl, can it be that in line 3 you are missing a D? Shouldn't it be bind gen?
Oh, thank you. I would have never found that. As I said, Visual Studio Code is not much help with the setup because it gets hella confused with the top level cargo terminal, but yay, thank you. It worked. Very nice. So let's look at a new manifest JSON. In our content scripts, we now have a second object that matches github.com and that loads our now GitHub logo replacement JS. So in the background, it automatically generated the GitHub logo replacement version and made this whole thing working. Let's go back to Firefox. No, not that one. That one. I already have a GitHub tab open here, and because some magic in the background, basically live reloading for the extension, it already printed out test. So every time we open a github.com website, it now prints test. So next thing is, how do I get to the logo? I have this GitHub logo up here, and with JavaScript, it would be easy. I would do just a query selector on this object and then would do some magic with it and yeah, just replace the SVG in here with an image. So to do that in Rust, we have to take a few more steps, which is one reason why I said this is only because I can, because it's not really the best or easiest way to get to the finish of what you want to do. First of all, we need, so let me start by saying we need WebSys. WebSys allows us, it's a crate that allows us to access the normal JavaScript APIs like document.querySelector in Rust. So let's add a dependency to our project. And I'm just going to copy paste here because we need quite a few features and I don't want to do that by hand. So the features of WebSys are very, it can be very broad because sometimes you just need a lot of stuff. Right, so back to the code file. First of all, to access our document in WebAssembly, we need a window. So the window is WebSys, then underscore, window. And we're going to error out. No global window exists, which should never be the case. And then we can access the document of that window we have now. That's window document. And again, we're going to error out if we don't find a document in a window, but again, this should not happen. Okay, so WebSys has a lot of little quirks that I needed to get used to coming from JavaScript. But in the end, it's really nice because I don't have to relearn the API. I now have my document and I can just make a query selector. It's spelled differently. So according to the best practices in Rust, it's snake, no, not snake case. It's an underscore in all small letters. In JavaScript, it would be written like that. So that's a difference. And just so you know where I get this query selector from, it's not the best thing because the A element here has no ID. So we have to trust GitHub to not change anything about it too much. And I chose to go with the A with the area label homepage as a query selector. If you don't know how query selectors work, they are basically CSS selectors. So in CSS, you could style the element by searching for A with the area label homepage, and you can use the same selector in JavaScript or in the query selector API. So this looks like this, and we need to, funnily enough, we can't use single quotes. We have to use the escaped quotes for the selector in here. Yeah, and we want to unwrap that, of course. So what we get with this query selector is an element. And yeah, I'm going to pause here for a moment. We're going to come back to the logo wrapper and how to change the element down there. What we need to do first, which I totally overlooked, is we need to create an image element. Before we can replace or to replace the SVG and the logo, we need an image element to place in there. We could, of course, just write text in there, but with an HTML image element, we automatically get the right thing. And I'm just going to import. WebSys exports all this these different elements as their own type, which must be a heck of a lot of work, but they are defined somewhere, so they export it that way. And we can just, yeah, we need an image URL because we need an image element. Sorry, I need to slow down a bit. I'm really nervous. This is my first talk. So we're gonna make a new image element. And we can error out here. It's not error. This, of course, should not happen either because you should always be able to create a new HTML image element. Right, so an HTML image element is this tag. And with the type, we get some things we can set, and one of those things, so we can set the attributes. Source is an attribute, and if you just create an HTML element, it doesn't have the attribute source. So it's really, I was surprised how strictly typed this stuff is at this point. Right, so we have a function that's named setSource. And yeah, what's our source? There's again a bit of magic going on. I already prepared a new GitHub logo, and those artifacts get copied to my package folder. So we have the PNG here too. But how do we access it? So with web extensions, we have what's called web accessible resources. And to get a URL to this resource, we need to use a special function. The function is called getURL. And yeah, so path. By the way, you can just name those parameters here and what you want. JavaScript doesn't care. It just cares about the order. And we need a macro. And this is in the namespace browser runtime. So if you have in JavaScript, this would be called browser runtime get URL. So if we have this namespacing with the dots, you can just use several namespaces at this point and just use the function directly that way. Okay, so we now can get to our URL. Let's make a new URL element or URL text above image URL. And let's just get URL. And here we can just use the direct path. We don't need a relative path because we are thinking of the top of the package folder here, or the same level at the manifest JSON. So we have our image URL, and we're gonna say, yeah, we're gonna set that as a source here. And now we have an image element that has a source. And from my testing, I already know that we need to set the width of this element to 84. Now we also need to do something else. And again, this is kind of, we do it in Rust because we can. We need to add a bit of styling because it's not vertically aligned that way. And that was a bit of a learning curve here because we can't set the style directly via set style, but with WebAssembly, we have to get the style context, some frameworks would say, and then in this style we have now, we set the CSS text. Well, that's a bit cumbersome, but again, I'm only doing this because I can in Rust, not because it's the best way to do it. You can just include CSS with with web extensions. It's really, really easy. So that wouldn't be a problem. Okay, so we have an image element with the right CSS class. How do we display it? And depending on if we found a logo wrapper up here, so we're back here, that's an option. So we don't know yet if we found one. And we're going to match that. And if we have some, we're going to set the inner HTML of this wrapper to image element outer HTML. That's honestly just something I use that way from JavaScript. I don't know if the outer HTML is needed here, but we need to get some text we want to put into the other text. So that works. And if we have no wrapper, we're gonna just log to the console. And the logo wrapper was not found. Okay. So a quick recap of the code. We search for an existing logo up here. Then we get the image URL, because when we use an extension, there's, I'm going to show you in a moment what the generated URL is. And then we search for the element on the page. Then we create a new element on the page, set some properties, and then we set the new element as the content of the old element. Let's see if this works. The build process is definitely not the fastest because I'm using a build RS that's doing quite some work. Log not found in the scope. Wait, where's the bind again? That's not the same error as before. Wait, we logged already from this, right? We had some test log here. Let me see. Get URL, wait, JS namespace. Of course. Let's see, this should work then. Yay, it worked. So nothing changed here because with our last run, we also already had the GitHub logo replacement. But I'm going to show you what a JS file, the generated JavaScript file does. This is prelude loaded by the Wesson-Pack crate. And in the end, at the bottom, we load, and we use the same get URL here we just used to generate URL to our Wesson file, and we run that through Wesson bind again. And this should result in, yeah, GitHub having a nice logo for the first time in its history from a really good product. So for those who don't know, this is the GitLab logo, and I kind of love GitLab. So it was a no-brainer for me to put the logo of the better product on here. As you can see, when I reload, there's a little delay in there, but we get the new GitHub logo, and we could do anything here. And we could, the way I altered this logo, we can alter anything on this website. So we could change all the colors to pink. We could change, I don't know, we could load in new fonts. We could make the buttons spin when we click it and stuff. So using the web extensions, you really have access to every part of the website, and even more depending on the browser. Okay, I'm gonna check time here right now because I have prepared 2 other extensions, but I think it's better right now to talk about the build process, and then we can see if I can get into the other stuff too. So,
Carl, can I sneak in a question here?
yeah.
Christian asks, would it be possible to somehow register also a handler function, like for instance, HTML button click or something like this, using Rust and such a tool?
Yes, you can. Let's wait a second. So the APIs are there. I know that. I just don't know at the top of my head what the exact syntax is. Basically, we have the logo wrapper here, and you can. It's a bit tricky because you can't pass a Rust function. You have to pass a JavaScript function, but you can pass a Rust lambda to call a Rust function. But yeah, you have the same API and can react to those events. Let me have a look. I don't think I have it in my examples anywhere. No, I don't have an on-click, but it's definitely possible. Okay.
Thank you.
I spent way too much on this time on this build process. Really, way too much time, but it was so much fun. I'm going to jump into the cargo toml a bit. I have this cargo uses toml, and I can just use my own keys in there and add new arrays and stuff. So what I did was I didn't want to manage 2 version strings. I didn't want to manage 2 authors and stuff. So I just thought, hey, it would be cool if I have it all in one place. And when I bump my Rust version, my crate version, I just get a correct manifest for it. So I did exactly that. And the web extension here, metadata web extension, is just stuff I use to generate the manifest to JSON in the end. So jump into the build RS. Create manifest is a really, really bad function because it's so big and not split it up. But anyways, it works. I read the cargo file, then I pass the cargo file, and then, yeah, I just save the Gecko ID, and the object is from the JSON crate, which allows me to create JavaScript objects on the fly. And then you can see here, I create a JavaScript object on the fly. That's my manifest JSON. So far, so good. We have content scripts and background where I put stuff in. We are not yet at the background, but I'm going to touch on it a bit later. And we set some variables, metadata. And what I did then is I just copy over the artifact path. And that's named script here. But, oh, yeah, right. That's named script here. It shouldn't be named script. It should be named file. But basically, what I do here is we have this web accessible resources. Wait. So if I don't put my logo into the web accessible resources, a web extension on GitHub cannot read my logo. Oh, wait, I promised you to show you the logo URL because that's containing the extension key. Wait a second. Just gonna copy this in so you can see it in big. So the get URL puts this whole mods extension, the extension ID in front of the GitHub logo. But we can't access this if the manifest doesn't know that this file should be accessed. So that's the reason I go through the artifacts folder here and put everything into the web accessible resources. Then I go through the permissions. This was the storage permission I mentioned earlier. And then I go through the content scripts. And in my cargo toml, I made something. I directly say, hey, that's not a JS file, that's a cargo toml. So if I'm going to skip a few things here, but the interesting part is here. If it's a JS file, I just push it into the JS portion of the script of the content scripts part. But if it's a toml extension, I search for, I have a little function that gets me a clean package name. And then I call a function that's named build script. And to build this WebAssembly, I use a grade that's called WasmPack. And the cool thing is that's usually a CLI command. So I would go onto my console. Let's change it to scripts, and I would say WasmPack hello Linz. I don't know the syntax right now. Well, maybe I have something in my history. Yes, there it is. WasmPack build est web hello Linz, and that's building WebAssembly with the, let's see where I put the hello Linz package. So I get the JS file, I get TypeScript definitions by default, and I get my WASM file. But I didn't just want to call some CLI command. I just imported the crate up here, WasmPack, and I'm using it directly in here. So those are the WasmPack build options. And this is the wesmpack command. And I'm running that directly in my build script, because that way I have way better control over error handling. Theoretically, in the end, it didn't matter, but it was fun to do. And yeah, so in the I need to adjust the JavaScript a bit, because usually the JavaScript just loads WASM bindgen, and then expects you to load your WASM yourself. So I didn't want to do that for every script I want to write in the future. So I load this whole thing into my memory. I add at the end this little WASM bindgen. Let me pick it out here. This was at the bottom. So this gets automatically placed for every script. And if I load two scripts into the same page, which, for example, if I have two separate scripts for github.com could happen, the let at the top of JavaScript, of the JavaScript code, let wasn't bindgen, I can't rebind the value. And so I'm wrapping this whole thing in an anonymous function that gets called. So that's some stuff I stumbled upon that was in a way of automating all the things. Yeah, but now I can relax and lean back and just let my build RS do all the things I don't need to do from hand. Yeah, so it builds my project here. And if it's successful, it pushes the JS file to my scripts from the content scripts, and it pushes my WASM file into the web accessible resources. Yeah, the rest of the build script is not that interesting. This is what it looks like if you just call a command. And so I could have used this to run wesmpack at this point, for example. But we're using Yarn to install the polyfill for Chrome and Edge. Yeah, that's the build RS. I don't know, from the timing, I could jump into the existing code and write a bit, talk a bit about what else I did. Are there any specific things you would like to see?
Feel free to do so. We have still 10 minutes left.
Okay.
I have currently no urgent questions here in Discord, and I'm very much enjoying your build script.
That's nice. So let's close this. I have, yeah, I'm just gonna jump in here. At some point, I had a little code that just showed me if you go on the web extension repository in GitHub, you get an alert in JavaScript that's saying, hey, you installed this extension on this and this day. And then I realized, hey, at the beginning, I had this code assigning the installation date when you first open the GitHub page. But you could install the extension and a week after visit your first GitHub page. So that's not really useful. So suddenly I had a second script that's running in the background that's called set real install date. So all this does is it gets the current time and it saves a setting. Now, the save setting accesses browser storage local. That's part of the web extension API to save settings of your extension. You could also in Firefox use sync, and just like that, you wrote an extension that syncs its settings with the Firefox account stuff. By the way, other detail here is the JS name for this function is set, but I renamed it to safe setting because it's a bit more clear what this function does when I use it down the line. And yeah, so I have this install time, and I have this install time in my alert here. Wait, here, install time. So this is where writing a web extension in Rust really shines, because using the whole Webpack module stuff is really, really hard to get working, because you have some cache files you need to, just like my WASM files, you need to, or code splitting it's called in the web world, you need to load into the web accessible resources. And the easiest way to just get it done is to just make it Internet Explorer 11 compatible. So you have one code file that's not importing stuff, and you can't use JavaScript modules. So you can't use modern web technologies like importing JavaScript from the files directly. So this is where I was. I think it's just cool that the way I built it here, I can use modules in my code without using a complicated Webpack setup. That's I tried it; it didn't work. Okay, so I have this shared folder, and here's my install time. So I just created a new crate that's named shared, and here I can put everything in that's needed at more than one place in my project. And yeah, this does nothing much. It gets the current date. It reports the current date if it wanted to. I don't even know what the get new install date. Oh, yes, that's the fallback. If we have an error in this already existing install time, because here we access the saved install time, and if that's empty, we request a new one and we return that. That's the logic here. Yeah, so this is just a pub mod, so it's exposed, and then I can use my install time in my other crates. By the way, you can just use path as dependencies, so that's the way I'm doing it here. That way you can use local crates as dependencies. Yeah. Are there any questions?
First, let me say thank you for the presentation so far, and thank you for sharing it with us. I personally love talks where you give the reason for why you do it because you can. It's really funny, and it was interesting, and I wasn't aware, or let's say I wasn't familiar with this technology. I have a question. I understood that many of the things you did was just because out of curiosity. Could you think of real world reasons where you would say, okay, if I had this or that problem, I would really use Rust for writing such a web extension, and I would prefer Rust over JavaScript, for instance?
Well, for me, it's a really complicated web extension. I would prefer to write in Rust just because of all the benefits like type safety. And also I have this module system without the, for me, really complicated Webpack setup, which I couldn't get to work. So for me, in the end, it was what was easier to use modules in the Rust world than it was to use modules in the JavaScript world. And as always with WebAssembly, I think it's the real benefit lies in applications that use the same code on a server part. So if you have a whole application with a defined data model, you don't have to think twice about how to parse it, how to use it. You can just import the same code and work the same way.
Okay, understand that. Christian was curious. He was thinking about exceptions in JavaScript and how you deal with JavaScript exception that are raised in Rust, or how do you handle an exception that happens in JavaScript when you call it from Rust?
Yeah, okay, so Weston Bindgen really is smart about this. I can only I can echo some things that are in the documentation. So with this up here, for example, you see we have an async function here. I could use a catch property and not make this async and return some value. So this way, Weston Bindgen would just error it out on the console, and I would never get an error here. But with other errors you let into your application, basically, you can just use, you get results and options. So it's the same thing you're used to. Let me jump back, I think, in the GitHub logo replacement here, it's properly, here Visual Studio properly displays the types. As you can see, my unwrap here gives me an option. So WebAssembly or Weston Bindgen just translates those things into results and options.
Okay, thank you. Thank you very much for answering this question. I asked the audience, do you have any additional questions? By the way, I was really impressed by your build script. I really enjoyed it. Will you by the way, will you share the location of the code? Can we take a look at it on GitHub or something?
Yeah, it's already live for a few days. I shared it in technical stuff or technical discussions
on
in
the Discord server. Okay,
Discord.
I see. Yeah, no, I see it. Okay, very good. So if you are interested in all this code and you want to take a look or benefit from the build script that Carl has written, take a look at the GitHub, at the Discord server in the technical discussion channel. You will find the link.
Yeah, and also I want to say, after I finish this whole thing, I think there's a better way to structure this. I don't think you need the separate crates. I think it would be far easier to just write one crate with very, very many public functions. And then you can just call the public functions from your generated JavaScript files. That would be another way to approach this.
Okay, Carl, I don't get any further questions now, but I've seen we got a lot of thumbs up on YouTube and things like that. So it seems that people were enjoying your talk and it was very interesting. It is a topic that normally many of us don't touch every day. So therefore, it was great to see how this is done. Thank you very much for taking the time. I can assume that it was a lot of time preparing this talk. We really enjoyed it. And I wasn't aware that this is the first talk of you. I personally think you did a great job. Thank you for joining us. Thank you for doing that. And yeah, in a real world setting, you would now get a big applause. But here, I just say thumbs up. Very good. Thank you very much for sharing this with us. Thank you, Carl.
It was a pleasure. Thank you.
Thank you, Carl. And with that, I would like to ask our second speaker. By the way, we are perfectly on time. We said at 6:30 we would like to continue with the second talk, and Carl had perfect time management. It's 6:30 sharp, and I can ask Klaus whether he is here, and he would like to share his screen and his thoughts about his Rust topics with us.
I'm still here, yeah. So
awesome.
I'm also going to share all of my screen.
Nice. For those of you who don't know Klaus, in the Rust Linz meetup, we always try to combine some international speakers and some locals. And today, Klaus is both. So we have found the holy grail. He is kind of local and kind of international speaker because Klaus, if I remember correctly, you are from Austria, even from Upper Austria. Is that correct?
Yeah, I grew up some 20 kilometers from Linz, close to Hagenberg. So
Very nice. So you see, we founded a Rust meetup to give you something back, and maybe in the future we'll come back and you can come back come back home physically to the Rust
yeah.
meetup. Klaus, we very much enjoy having you here, and with that, the stage is yours. We are looking forward to your talk.
All right. So yeah, welcome to from WebAssembly to another topic that is a little bit more down to the metal. In this case, it's trusted computing with Rust on Intel SGX. And yeah, this is also similar to WebAssembly. It's no STD, but WebAssembly has already the working group has already done a good job on translating most of the things in there that come with the standard library. So yeah, as you took you already took that sort of forward. I grew up in close to Linz. I live now in Amsterdam, and I've not lived in Austria for like 7 or 8 years. So, but in the meantime, I've written 2 Rust books. You can find the links to that on my blog. It's about algorithms and data structures and the Rust cookbook. Yeah, so I do all kinds of different areas in that respect. So yeah, what is trusted computing? I think everybody kind of knows the tired already saying that the cloud is just someone else's computer. But the reality is you cannot really make sure that what you run on someone else's computer is actually what you wanted to run and that nobody is really sort of listening. Well, that sounds a little bit paranoid. There are some valid use cases to having that. So how do you verify that the code and the data that you're running are really the things that you wanted to run? So use cases, what would be, so crypto finance is a fairly recent one, but in general finance, a particular example is something called the town crier architecture, which makes sure that the data you're receiving on a machine and you're basing your financial decisions on are not being spoofed by an intermediary party, right? So you make sure that with TLS encryption, that the origin of your data is really that the data that you're like intending to get, right? So the other person, the other party is saying is really who they say they are. And the second thing is that the code that is making your financial decisions and potentially, betting your livelihood on something is really the code that you wanted to run and not something that, some root user that you never intended to have kind of is changing or altering this code. 1Password, on the other hand, has a different use case, is using Intel SGX to secure sort of the password storage and retrieval on Windows, I think only. And so authentication security. So it doesn't unpack everything into memory, because if someone had access to that particular computer or that memory, they would can be able to create a memory dump and therefore have unlimited time to crack your passwords or crack the sort of the encryption that is being used, maybe, or even if it's unencrypted in memory, which it typically is, just read the passwords really. And yeah, verifiable integrity is important in a sense where we all kind of know that there are zero-day exploits and other things that like cyber attacks in a way that do remote code injection, where they especially, Rust protects against that by definition as the language, where you cannot change return addresses or something like that easily. But it happens, and you still kind of there's other ways to inject code while sort of you're not looking, right? And in the cloud, this is happening on this is potentially happening on a larger scale. So Intel wanted to come up with a solution to that, and they have worked on that since 2015, and the work is ongoing, and it's called Software Guard Extensions, or SGX for short, and it's an encrypted CPU enclave. So what that really is a part of the CPU and a separate instruction set that is encrypted in at runtime and at rest. So it's encrypted all the time. It runs on its own instruction set. The CPU even blocks a particular part of the memory that you cannot access from the operating system. So the goal is really to ensure that whatever you're running in there is confidential, and with a different set of keys, it also guarantees that that the integrity is really guaranteed, and that even if you don't know who is running the operating system, or really who is who has access to this stuff. So a little bit more about Intel SGX. I have come across that recently in the consulting work that I do, and it's really interesting to see sort of what that how that has a really particular influence on the way you program. Especially, this is all hardware. So if you think about, it's like your hardware, your CPU has two extra keys that come out of the factory. Really, one is called the root provisioning key, RPK, and that is sort of Intel's master key. So by extension, you don't trust your cloud provider, but you have to trust Intel on that. And the second one is the RSK, the root, the sealed key, essentially the root sealed key, and that is specific for your CPU. So, and that is also unknown to Intel, but it's derived from the provisioning key. The part that in memory that is really encrypted is part of the regular RAM, right? But the encryption key is reset every power cycle, so it's impossible to do a replay or a simple replay attack where you just take memory snapshots, for example. And without conventional, without access, it's basically impossible to do any sort of attack on that. And conventional means without opening up and using UV lights and observing the sort of the electrical currents inside the CPU. So then you need that's a really in-depth attack. So programming for SGX, obviously that's a C and C++ territory, and since everything is encrypted and everything uses its own CPU instruction sets and works on a specialized set of memory, it has to generate proxies, right? So you have to dynamically link to a library, and that library has proxies generated for each function that is publicly exposed. And this is typically done with an enclave definition language, or EDL for short. And you declare those interfaces. The build script generates those proxies, and then you can sort of use it as a normal library. And yeah, Intel provides a nice developer manual that's only 400 pages to get into it quickly. So an application, an SGX-based application, has two parts, and trusted part and an untrusted part. So the trusted part is anything that runs inside of the enclave. Untrusted part is your regular application that calls inside of the enclave. So you typically wouldn't have the entire thing running there, but only the parts you really want to have, since it's fairly expensive to kind of call back and forth, and it's also fairly hard to achieve some things, since you're lacking like a libc and these types of things. So how do you communicate between those two parts? These two parts can be can call each other, and those things are called e-calls, so into the enclave, and o-calls, so out of the enclave. And yeah, the proxy generation is done by the build script and creates a it generates the code that can then ultimately be called. As this is no STD, so everything is encrypted and this means it needs a specialist memory allocator. And that means also that, you can maybe translate some things. You can still have like vectors and strings and stuff like that, but they can be limited by this allocator that is being provided there. And it's a little bit different, but it's also quite similar. There's a link at the end for people who want to get really deep into this, how the memory pages look like and what the thread memory allocation pattern looks like. So to get really to really look at memory layout diagrams. And that's definitely a very deeply technical topic. Then when you run,
a question: is it okay if I relay some questions that come up to you during your talk?
Yes. Sorry, for sure.
No, absolutely. Rumbo is asking whether the stuff in the enclave is running in parallel to the operating system, like in ARM trust zones.
Yes, it's running in parallel. Yeah, we'll see that later in the code examples, that you start up the enclave whenever, in the beginning of your program, and until you sort of shut it down, it exists, and you can run threads in it, for example, as well.
Okay, thank you.
So when you run something in the enclave, you want to make sure that it actually ran in the enclave and that not someone spoofed your, the sort of the call there. So you need something that's called attestation, and attestation is nothing really special. It's uses encryption, or uses the cryptography to sign the code or sign the message that comes out of the enclave with the special the RSK, so the root sealed key. And therefore it can be, since this is derived from the RPK, from the root provisioning key, you can always verify that this signature has been generated by the sealed key of a different CPU. And this is called, when you do it on a second computer that also has an enclave, this is called local attestation. And if you do that with a web service, which Intel provides, and also all the cloud providers that provide these machines, they also provide a remote attestation service, which is a web service where you can just send the signature and have it sort of a thumbs up, a thumbs down that this is running on this has been running in a specific enclave. So this is a short diagram how this works, right? You see your application that calls into the enclave, does some stuff, signs it with signs this user data with a special key that is from somewhere, gives it back to the application, has maybe a different, so this is from a specific application, so this has two enclaves here. And then the challenger is the person, or someone who wants to know, is this real, and sends this this user message essentially into through the attestation verification, and can then say, yeah, I trust this result, or I don't trust this result. That could be, for example, very useful in a way when you have a distributed application where everybody sort of in a blockchain manner adds data to a blockchain, and that data, you want to know that this has been processed with the same algorithm as everybody else, and therefore you want to have it attested by everyone. And by just providing the key, or as part of the message in the blockchain, everybody can sort of verify that all of this data has been generated as expected. So obviously, C++ has is a little less fun, let's say, to program than Rust. And this is why they came up, Baidu in this case. So they wanted to keep some stuff confidential, apparently. So they came up with a Rust SDK, and Rust in general is a good fit, in I think, given the memory safety for this type of application. And in the meantime, so I think it was Baidu Labs, and it was at a RustFest presentation in Rome, I think, which is 2 years ago or something. And after that, it got picked up by Apache in the incubator, and it's under active development. So it has a new version every couple of weeks. And yeah, you can find it on GitHub, and we'll walk through this SDK in a minute, so you'll be proficient in using it and jumping in right away. So the requirements, what do you need to run sort of this code? So for Mac and Windows, you do need Docker and run Docker containers, because that's for software emulation of that of the driver. So the Rust SDK does not yet work with Windows. There you have to stick to C++, and the Mac doesn't expose the Intel SGX drivers at all. So if you want to get into compiling your own drivers for the Mac, I'm sure that there's a lot to be learned. But the easiest way is to run Baidu's Docker container using using software emulation of the of the enclave. You also need a new-ish Intel CPU, so 2015 and later, and then you're likely to be able to run a SGX version 1 enclave. So this is the thing that I'm running here is Lenovo Yoga X1 from 2017, and that supports like almost all of the instructions, but there's a second generation SGX enclave that is upcoming, and for this it lacks one CPU instruction set. So it's kind of a little bit of a gamble if you have it, but if you have it and run Linux, you can actually do all of that locally. And for that, you also need to, first of all, activate it in your BIOS or AFI, and then compile the drivers so you get a sort of a generic device, dev SGX device. And yeah, you can also rent a cloud cloud computing for that, like a cloud VM on Azure. There's Azure Confidential Compute, or I think Alibaba has some, as well as Amazon, and probably others that I don't know of.
Klaus, we have one question which somehow relates to this slide. One person in the audience would like to know whether SGX is really Intel exclusive, and whether there is something compatible or similar in, for instance, the AMD Ryzen area or something like this.
So Intel, the SGX, the Trusted Compute Platform, is, I think, Intel exclusive, but most websites that I read said that AMD has something, but it's not as extensive. So and I didn't find what it was. I think it has some minor parts, but right now I have not seen anything that is sort of that you could use in both on both like processors.
Okay,
unfortunately, yeah. So the Rust SDK itself is quite extensive already. It has many patched versions of STD classes and structs in there. It has a ton of different different code, and it's quite complex in that it provides specialized versions of the threads and also some vectors, and or the vector, and I think the hash brown crate, and some of the cryptography stuff in there as well. So you can use basic cryptography, although for example, Rust TLS also has a no STD version that also works really well in the enclave. The only downside is that you are relying on a lot of patched stuff, so it's incompatible with like with all the good stuff that is currently, is a little bit newer, like Tokyo, or if you want to do some other, like not use the Rust TLS with no STD, but want to use, for example, connect to a WebSocket or something like that, where you want to have a secure WebSocket implementation that you don't have to do all of the things yourself. So yeah, but I think it's getting there since it's active development, and there's also something called Mesa Linux, which is, I think, a Linux distribution that is focusing a lot on SGX and the secure and trusted environments. And from there, they seem to have patched almost any useful crate, starting from CRD JSON to all kinds of other things that usually don't provide a no STD version. Unfortunately, not WebSockets though. So let's look at some of the examples. So the website is, everybody knows GitHub, and everything is on GitHub. So fairly recently they released version 1.13 of the SDK. And yeah, the SDK itself, as you can see, there's a ton of stuff that that is sort of trying to emulate STD and specific types that also kind of you need, like sealing and unsealing and stuff like that is here for working with the enclave. But let's not work on a web browser, but rather a terminal. I think that's probably more realistic. A little bit larger. So in this case, this is a Azure Confidential Compute VM. So I didn't run this locally because I messed up the drivers, which happens. And it runs best on Ubuntu, and this I'm running here Fedora. So yeah, that's it. It does work on Fedora, but not in the same like it's easier, better compatible with Ubuntu. The sample code that they provide is much better than whatever I could come up with as an example. And in fact, the company I'm working with is basing a lot of their code also on the sample code, because it is quite complex to program anything that works with their build system specifically. So you can see there's a few examples in there, like starting from a regular hello world. This is I think actually C++ mostly, but there's a hello Rust that is completely done in Rust. Debugging is interesting because in a production enclave, debugging is actually impossible to do. So there's no way to attach a GDB or something like that to the debug symbols of the running of the running code. One interesting thing is also TLS that we are going to look at. So the TLS is verifying that the remote party is the remote party by just making sure that the certificates match, for example. And if you do that in the enclave, then you actually have an encrypted data stream that the outside party cannot read. So anyone outside of the enclave cannot read what you're exchanging there. There's also some machine learning for those of you who want to do some machine learning inside of the enclave. That is quite interesting to see, but it's it's more of the easy stuff. So it's not exactly a deep learning experience that you have there, but rather I think a k-means, so a k-means classification even. So it's not very sophisticated, but it's a translation of or a patched version of Rusty machine, I think. Then and last but not least, we are going to look at the unit tests, because as good engineers, we want to test our code, and obviously that should also apply to stuff that is running in the enclave, because obviously without the standard library, we don't have a testing framework. So there's a way that they came up with that is quite nice to run tests actually. So as we go forward a little bit in time, so I did this not too long ago. So the preferred way to run and work with SGX is in a Docker container. So in this case, I did Docker run, map the current volume into root SGX, map the device as an enclave in there, and use the Baidu XLab SGX Rust Ubuntu container with Ubuntu 18.04. With the newest Rust SDK also supports 20.04, but I didn't see it yet. So we're working with the old the old SDK in there. Then there's something that is called the AESM service, which manages sort of the enclave access. So it needs to run in the background, and the Docker containers don't have that running by default for some reason, probably because you can also map in a socket and use your outside, right? In this case, I could use the outside thing as well because it's installed on the Azure Confidential Compute VM as well. So if we go into or CD into this SGX sample code thing, and we want to execute the hello Rust or look in the hello Rust thing, we have to run a makefile, and we'll look at that in a second. And then it downloads everything because we didn't map it in. It doesn't have a Rust installed by default either. So it downloads everything, and then eventually in that makefile, it also links everything together ultimately. So it creates a native library or two native libraries really, and maps it all together, like links it together with the generated enclave proxies, and then outputs the enclave configuration, and then it says, yeah, it's done. So, and then you have something in the bin folder, and you can execute that, and then the result is hopefully something successful. So let's look at what that looks like in code. Maybe also a little bit bigger. So this is again the Hello Rust tutorial. I'm SSH'd into this machine again. And so we see that this is the main RS. So these are the two parts. We have the app part here, and we have the enclave part here. So this is the untrusted part, is your regular Rust program, and the enclave part is your trusted environment here. And there's all kinds of other things to support that. So this is the makefile that we called earlier. This makefile, does. If you enjoy reading makefiles, that is this is definitely a good read. But the important part is here that the SGX mode is here set to hardware, which means that it tries to build it with the device that is called dev SGX / enclave, which is the newest driver that you can do. Previous drivers had like a dev ISGX device instead. This is what you have to call to build it. It does a lot of stuff. I didn't really find everything that I wanted to do in terms of linking, but because I feel like we could probably build more of that into the Rust build system, but maybe later. So we see that. So first, in the untrusted part, it uses a little bit of an older coding style, which is older, a little bit more C-like coding style as well. And any of the trusted functions are imported using an extern statement. So this is just like as if you would interact with any kind of C library, any kind of native code. And you have specific types, and these types are obviously generated at runtime or at compile time rather. And you have in a typical C fashion, you have return values that come out as an out parameter, and you have a sort of a status return value of the function. this is the init part. So you initialize the enclave. You create sort of, you call this create enclave file with a few parameters, and then this returns yeah, in a typical fashion SGX results. So yeah, it's a normal result with an SGX error. And
Klaus, before we go into the main method, can I ask you a favor?
yeah,
There is a kind of flickering when screen sharing.
ah,
We always see your beautiful car in the background. I think it's a Rolls Royce. What we shouldn't see. It wasn't that bad while we were looking at the slides, but
mm,
now when looking at the code, it's kind of um, disturbing. Can we try to stop screen sharing and re-share again just to give it a try?
yeah, we can. But just to say, this is a problem that I've always had, and I don't know what it is. I think it's
Ah,
probably
okay. So it will probably not go away. Okay,
it
let's give it
probably
a
not go
try, and
away.
if not, we'll accept that. We can still read the code, but yeah,
Yeah,
it's worthwhile trying.
yeah, and I think, I mean, I can try maybe sharing that specific window,
Ah, good idea.
but yeah, we'll see if that changes something. Is that? I think this is what I'm looking at. All right. Does that change something?
No, it still flickers, but I
Oh,
think if you move your mouse as little as possible, it's best. But it's
okay,
okay.
great.
We can read the code.
Yeah,
It's fine. So please
yeah.
go on. It's very interesting, and we have a lot of discussion going on, and it's very good. So yeah,
All
we
right,
will
then I'll
not let ourselves disturbed here.
yeah, and I'll try not to move my mouse a lot. So the main function, this is a hello world example. So it's pretty simple. It creates a string, and it also uses the string, like the string as a pointer. If you have ever done any sort of native code interaction with Rust, this is exactly the way to do it. This is you have an unsafe function, you have an unsafe scope. You call that function, that external function, in that unsafe scope, and you have to do everything again as a pointer, just as if you would do in C, which is kind of unsafe. The short, well, in short, it's more C-like, and it has to, in this case, and in every case really, that has to do with language interop. The Rust compiler can't guarantee any memory safety, which is why it's unsafe to call in there, and everybody has to kind of work out when to free the memory on their own. So calling across this, as you can see, is fairly easy. If you have ever done any C interoperability, this is basically the same. So then let's look at the enclave code. So this expectedly, this will have to be linked to something. So this uses dynamic linking. And in that case, that means we have a build.rs file. And that build.rs file talks about that, or rather, it uses the linking, the dynamic linking that you would use. And it communicates, for those of you who've never done that, it communicates over the standard out, which is quite funny. I thought it was like such a simple way to communicate between the tools, but it works well, obviously. So enclave code. The enclave is a fairly regular library, so you can see that this is a static library, and it's a no STD library, so they use the sort of the attributes to do that. You could, I think, do that same thing in the cargo toml. And there you also have to do the extern crate declarations as well. So that's something different. And as you can see, they use, even though it says no STD, they use STD imports in lines 30 to 33. And the reason they can do that is because the SGX TSTD, so the trusted standard library, is sort of aliased as STD. So this can be maybe a little bit confusing. I'm still torn about this practice, if that is a good practice or not. But essentially what that gives you is a similar structure than in a regular standard library, and even comes with their own types like strings and vectors and stuff like that. Even re-exports of traits like the write and read trait, which is quite cool. And yeah, you can even read, files and stuff like that. So again, as with regular language interop with native code, is the no mangle attribute. And that means that the compiler doesn't change the name, so it doesn't do name mangling in order to preserve the name, so it can do a dynamic lookup of the function. And the same thing, it has to do an extern C, so it also allocates sort of the function name in a specific part of the library. So if you look at DLLs and SO, also shared object libraries on Linux, they all have a particular way of memory layout where they put in the function names, and then they, other languages can look them up as if they were native libraries. There's again sort of, this is all safe code, except for a few of these sort of the stuff that comes in has to be, right, all the parameters then have to be again added to a memory layout and potentially casted, which is something that Rust doesn't really do in a safe way, or can do in a safe way, but usually from pointer to a different type of pointer, it doesn't really like to do in a safe way. Therefore, there's a few unsafe things that you always have to do when working with these incoming types. Then not much, not very special here. You can even use the vec macro, and all this is a no std environment, and it looks very, very like a regular Rust program, which is quite cool, and is quite is impressive actually to how well they did here, I think. But looking at the cargo toml, that looks a little bit different. It definitely looks a little bit excessive for their dependencies that they added here. And these dependencies are sort of for build reasons there, I suppose, because they're all sort of outside of the target environment of SGX. So if you look at the qualifier on line 13, these are all the dependencies when it's not in an SGX environment. Then the enclave itself can be configured. So that's a config. There's an XML config file that goes with the enclave, which gives it sort of where you can define heap size, stack size. TCS num and TCS policy is about threading. So you have to define the number of threads beforehand. And the TCS policy, there's two types of threads. They're bounded and unbounded threads. And currently only bounded threads are supported. So then you actually have to put a 0 there. But otherwise it just panics. So that's something for if you want to dive into C++, and I bet the developer's guide has something to say about that. That's a different way of doing it. I think bounded threads are sort of bounded together with outside, so untrusted threads, but yeah, in some way that I didn't explore too deeply yet. So the second thing that I wanted to look at with you is the TLS part. So TLS is a client and a server, so two independent applications. Again, the app, so the untrusted part is fairly straightforward. You have a lot more imported functions, and in this case, after the initialization of the enclave, there's a lot of code, as you can see on the right. There's a lot of code there, and that is essentially a TLS client. And that TLS client is, if you look up the Rust TLS client example, it's exactly that thing. So this is the Rust TLS client, and it uses a Mio to kind of work on the stream to see when it has to read and when it has to write. So it's It's one way. It's not that terribly complex, but it's definitely too much for me to walk you through this. But yeah, you have a certificate, you have a host name, and then it does it uses a sort of a buffer internally. Usually, it uses a buffer internally that does the so first it reads stuff into its buffer, and then it tries to decrypt it using the provided certificate. And in this case, we do the decrypting and the reading of the actual data inside the enclave. So every read TLS call on line 156 and is forwarded into the enclave. So in 159, you see that this is calling into the enclave to read a buffer. And once that results in something, well, just it hands it forward into the current buffer. And I think in this case, it just prints it out on the standard out. And it does the plating here. Here it does the printing on 206. And yeah, that's sort of what it does, right? It just prints it to standard out. The main function itself, again, init the enclave, just as before. It uses it disconnects to the local server, so to the server part here, does all the sort of connecting in different ways, instantiates the TLS client. The TLS client in turn goes into the enclave and creates the TLS client there. So that this case, and this is why I wanted to show it to you, is the enclave is also holding a state internally. So every time we call into the enclave, even though these are independent function calls, we do get the same state internally. So we get the same TLS client internally that holds the certificate and that knows sort of, that this is sort of, this is an ongoing conversation, if you want, an ongoing stream in that sense. So yeah, fairly straightforward. We send the HTTP request as raw as possible in there, and then it loops and waits for events to come back, and then exit after that. But the more interesting parts are inside the enclave. So inside the enclave, again, single librs file. Doesn't have to be that way, but it is in this case. This has a lot more sort of imports from different, parts of the new sort of trusted standard library. And it comes with, as I said, sometimes there are specific types like an SGX RW lock, so a read-write lock, and also SGX mutex, which is different than a regular mutex, obviously, because it's inside that encrypted part. And here it's also using the no STD version of RustTLS and a patched version of WebPKI. And we'll see that later on. So it also uses lazy static, or rather, it uses lazy static to create a hash map, which, a locked hash map, which is used to create to cache those the TLS client in between calls. So again, this is sort of the same structure as in the untrusted part. So it has a read, write, do write, but it also has a persistent cache here, which is what it uses to hold on to that data internally. And once that once that is created in a new client, you see it creates a box. So it allocates heap memory and puts that heap memory, puts that box into a new session, and that new session registers itself in the global context using a specific ID and the current enclave ID. So then it associates. It has this lazy static global memory sort of, and registers the pointer with and associates it with the enclave ID, and therefore carries over in between different calls. It carries over what's what's in that current TLS client. And that's quite interesting. It's not very easy to read, let's say like that, but it's very interesting how that works. I see it as a session ID for the read. So you create it at one point in time. And then on line 310, you call read after some time. You use the session ID and use it on to fetch your session pointer and cast it. So line 317 and line 318 do exactly that. So they fetch the session out of that global registry and transmute it or kind of cast it unsafe into the session pointer, and then can call obviously those functions on that. So yeah, and then in this case, the reading is done, right? And after the reading, it uses copies the plain text into the output buffer and returns a positive integer, like the number of bytes it read, which is quite typical for any type of C programming. And this sample code in general is very much C-like, not very Rust-like from a coding style. So something that we didn't look at before. So we define all of these external functions in an EDL file. And this EDL file looks very much like a regular interface definition language that you've seen before, maybe. So it imports all of the different extension, or rather the other things that are trusted calls. And if you wanted to add something here, like threading, for example, this would lead to another import statement that you'd have here. The e-calls, so the calls into the enclave, are part of the trusted scope. And if you had O calls, so outside or back outside, like a callback or something like that, that would be an untrusted scope. So it would be exactly the same like here, right? It would use the same data types, and if you had here, and they would call untrusted, and then you would have O calls defined in there that you would be able to use from inside that librs. All right. So for those wondering, there's also a Xargo toml here. Xargo is a cross compilation toolkit, let's say, and it's not used unless you wanted to, unless you want to use it. It's just a normal, I think a config flag that you want to have it used here. Xargo SDK, SGX. I didn't use it, and I didn't have the impression that you have to.
Klaus, can I relay a question to you?
Yeah.
We have a question. Does the SGX execution context have a different memory model compared to vanilla x86 because you use fences?
I don't know. I would assume that that there's a bunch of different things, since it blocks off part of the memory. But yeah, I don't know. I would assume yes, but I don't know.
Okay, no problem.
Yeah. So this is already the last one to show, but it's a lot of stuff. So in this case, this is when I executed, when I built the server and the client earlier. We can run it again, but essentially this is going to be output. So running the server and then connecting with the client is simple, and as you can see, this works. I think we should. Yeah, I don't think we have to run this particular one, because we can move on to the last code, and arguably the most important, unit testing. So why is it the most
before
important?
you move on, can I ask you another question before we
Sure.
can you elaborate a little bit more about real world scenarios where this TLS client and or TLS server would come in handy? Something what would be possible through SGX and enclaves, what wouldn't be possible otherwise?
Yeah. So for the TLS server, I guess the same thing applies that I'm gonna now say about the TLS client. So in this case, this here. So we create a TLS client here, and we put in the enclave, and we put in a host name and a certificate. So if you wanted to make it really secure, you would not do that. You would probably deliver the certificate as part of the application. As part of the application. What that means is that you have a public key of something to encrypt the communication between you and the other party. So that could be a web server. If you use, for example, a crypto exchange, if you wanted a cryptocurrency exchange that you want to call, you use the public key, add that to your application, so you don't have to read it from a potentially a spoofed file, right? And encrypt your communication essentially between inside the enclave and this exchange API. So what that means is that no one from the outside, so the outside only has the socket, but doesn't have the encryption key. So the encryption will sort of any party listening on that socket or doing a memory dump will not know what you are actually communicating between the enclave and your other party, your trusted party. So that does two things. Not only can you have a secret data exchange that your host doesn't know about, but you can also verify that the other party is actually the party that you're talking to. So in this case, that would mean if you wanted to have finance data and sort of do automated trading, for example, or have a distributed data collection that anyone can run in a similar fashion that that you would do like a SETI at home or something like that. Everybody can participate in that data collection without you having to know that person or trust that person, that they don't mess with your data in order to get sort of an advantage. So what it does is essentially that enclave can then fetch data from that exchange, for example, trading data, do something with it, apply your secret or not secret algorithm, and make trading decisions based on that. And you can only make really trading decisions if you're absolutely sure that the other thing, that the other party or the data you're basing those decisions on is really the data you're expecting and thinking about. And while this is a finance example, I think there are other examples where this is interesting too. Like you could do information exchange without processing that specifically for financial trading, but you could make decisions based on data, and that you can be sure that this data is only read by, the data that's been sent is only read by inside the enclave, and what goes out of the enclave is maybe only the decision that has been made based on that data. So that would be one fairly, I think, a fairly significant example, because it doesn't really mean you have to trust which hardware it runs on. So this could be anything really from machine-based interactions, right? You imagine your car buying a parking ticket or something like that. You don't have to trust that whoever implements the software is kind of trying to cheat you, because you know that the enclave is running that particular code, and you know that this communication is first of all verified that this is your code, so it does pay for the parking ticket actually, and not just send a number. And the second thing is that this is not really, if you had more sensitive parking ticket, is not very sensitive, but if it was your garage door opener or something like that, you would want to have that encrypted as well. So there's different applications for that, and this is what I'm now talking about is fairly specifically the town crier architecture paper. So if you Google that, you'll find the town crier architecture as a thing there.
Thank you very much. That clarifies a lot. Thank you.
All right. So unit testing. As good engineers, we want to unit test our stuff most of the time. And this is also possible to do it within the enclave. So again, same structure. You have an app part and you have an enclave part. And the app part has again a main function. In this case, it doesn't have to be the main function. You could also have, if you have a library, you could also do the same thing in a test function that is outside. It's just regular Rust unit testing. And yeah, importing the test main entrance function, as they named it, and running that will yield you, will run all of the tests. So what's the really interesting part, therefore, is happening in the enclave. And as you can see, they have built a bunch of modules for that and chained it all together in the librs, and also created a SGXT unit test crate for use. And then a macro to kind of run all of these tests. Yeah, because it's probably more convenient. And yeah, so a ton of tests. And the reason why it's also important for this SDK is it shows you how to use all of the features that don't have sample codes. And that is, I think, fairly significant, especially if you wanted to build threads, because threading is not that easy, as it turns out, because the documentation is a bit scarce, let's say, on that. So this looks fairly normal, right? Thread spawn, nothing specific on that. You can also use a thread builder to work on that. But what the difference is that all of this has to be, first of all, declared in the EDL. So working on the threads here is that. Then you have config stuff that has to be changed. So in this case, we can build up to 10 threads, which is useful for unit tests in general. And the threading policy is not 1, but 0, meaning that it has bounded threads, and it uses the way that the only way that the SDK recognizes threads. And other things are similar like that, right? So how to use the random generator, for example, in there. So it has its own random generator, well, rather a patched version, I would assume, because a random generator is otherwise a feature of the operating system. And similarly, how to use the patched version of serialized of JSON serialization there. And yeah, other things like how to use asserts, which is it comes obviously also with similar functions or macros in this case, like the should panic and the assert macros that also I think are otherwise only available in the standard library. And yeah, there are different things in there that I didn't find a place apparently in the other samples, like reading files, writing files, and yeah, timekeeping, because obviously timing is also something that the operating system provides. But if you don't trust the operating system, it's very hard to time things. And yeah, it goes on like that. There's a lot of stuff in there. I think this is probably the most complete imports that the entire sample set has, and it shows that there's a few things in there that are really, really useful. As you can see, that this has regular dependencies, like stuff that comes from crates.io, but most of the times you would have some sort of a Mesa Linux version of regular crates. And if we run that, and this is the one that we are gonna actually, so this is the way that you have to work when you're doing sort of SGX based programming. So you're inside sort of the root folder of your project. You run make. You see that I ran make before, therefore it's not a lot of compiling. But you see that there's again the enclave configuration as the output, and it has a lot more memory than the others, which is also interesting. I've not run into an out of memory problem yet, but it seemed to have had that. And then you have to really change your working directory into the bin folder and run the app. If you don't do that, then you get a weird exception, which is costs a little bit of headache. And as you can see, this is fairly similar to what we would have in regular Rust unit testing. And there's the few exceptions that are shown here. Also, as in regular Rust unit testing, shows you the panics and accepts them if the test says it should panic. And yeah, as you can see, 199 unit tests in there, and all of them passed. And yeah, it's quite interesting, I think, that it works like that. And you can create basically a regular tested application inside the enclave, call and combine it with your regular tests from your untrusted code, and therefore, follow good engineering practice, I guess, and still have trusted and untrusted division. So and that's it. So you can I'll send out the link for this. If you didn't type it already into your browser, I can send you this presentation. So these are the 3 examples. And yeah, so thanks for listening to me rant. And I think this is the last chance for questions, maybe. But yeah, otherwise, I blog sometimes on my blog. There's also where you can find my books if you're interested. And yeah, other than that, thank you.
Thank you very much. This is the first chance for me to say thank you. Thank you for this awesome talk. It was really interesting and it made me think a lot. I personally do a lot of work in the cloud computing space. I have been doing that for 10 years now. And I think this might be really a game changer for some applications because, especially here in Europe, we have a lot of discussion going on whether we should trust US companies running clouds and so on, and how can we do critical workload in cloud data centers, which are obviously useful, but we don't trust 100%, maybe only 95%. And I guess this is really a very interesting option that, as I said, might be a big game changer. What would be interesting for me, and I encourage everybody to ask questions over Discord. I have a look at Discord, but one question comes from my side. Did you already use that in a real world project? I'm not asking for specifics or NDA breaks, but just any experiences from real world on your side?
Well, it's not in production yet, but the company I'm working with as a freelance consulting is looking to launch end of December, and in this case, it's a crypto finance thing, and this is fairly pretty much what I talked about as a real world example. It's a little bit more sophisticated than that, but yes, this is that. And another thing that is not from me personally, but 1Password has been using SGX for encrypting their password vault since I think a couple of years, since 2017 or something, on Windows.
Okay, I see. So they don't use it on the cloud side, but they use it on the client side, right?
Yeah.
Okay.
If available, it's not that easy yet. Yeah, it's deactivated by default, for example. I don't know why, but it is.
Okay. In your project, did you really use Rust for implementing the enclave code, or did you go for C++?
Rust. Yeah.
Rust. I see. Very interesting. Very interesting. I take a look at Discord whether we have any additional questions. I don't think so. Klaus, let me say thank you very much for this great talk. Oh, some people are just typing. Oh, awesome talk. Not Matthias is telling us that Signal is also using SGX.
Oh, okay. Great. So there's another use case then.
Okay, that's another use case. Okay. Yeah. Klaus, if you can and if you like, you can join us on Discord. Maybe you can hang around for a little bit longer. I'm not sure if you are already on our Discord server. If you are not, you are very much invited. With that, people can maybe ask some questions, or they can use your URL that you just shared here to get maybe in contact with you via Twitter or something like this.
Yeah,
Is that okay?
yeah, yeah. It's great. I
Yeah.
joined like an hour or something ago, so uh, I didn't claim my name yet, but you find me in there. I think right
Okay.
now.
Great. Okay. Thank you very much. It would be great if you could join your slide link for those people who would like to give it a try, who would really dive into this stuff and try it on your own. And yeah, let me say thank you and wish you a nice evening, and we'll see each other on this course. For everybody else, thank you for visiting the Rust Meetup Linz again. We are very happy to have you. We will definitely try to schedule another Rust Meetup in December. We don't have a fixed program yet. We have some things in mind, but let me quickly point that out. If you go to rust-linz.at, we are always looking for interesting topics. So if you have a Rust project or it's just an experiment, if you have deep dive content, or maybe if you are a beginner and you would like to share your experiences with starting Rust with us, don't hesitate to contact us. You can find, as I said, the Sessionize link on the website, rust-linz.at. Please give it a try, come to us and share your knowledge and experience with us. We would really appreciate that. Thank you very much for visiting us. Have a nice day. Have a nice evening. See you at the next Rust Meetup Linz. Goodbye.